Now, in this lecture, I am going to talk about elastic collision in one dimension, and I'm talking it for the laboratory frame of reference. So, consider two particles, and particles are supposed to move along x-axis. Say this is y-axis. Let us call this is at origin. And initially, one particle is at this point and it is moving along positive x direction with velocity u1. There is another particle whose mass is m2 and it is moving along positive axis with u2 velocity, and as assuming that u1 is greater than u2, and say this is the origin of the laboratory frame of reference. So here initial velocities are these, means before collision, and after collision their velocities will become v1 and v2. So initial velocities u1 and u2, and their masses are m1 and m2, and this is before collision. And if there is collision, means after collision, masses will remain the same, but their velocities may change. So it is v1. Let us call this is v1 and this is v2. These are the final velocities. Since it is a elastic collision, so that means both momentum and energy will conserve. So according to law of conservation of momentum and law of conservation of energy, that before collision momentum of first particle or the first object will be m1 u1, and for the second it is m2 u2. So this is the initial momentum, and it is equal to m1 v1 plus m2 v2, and this is the final momentum, and this is initial momentum before collision, and this is after collision. And let me call this as equation number 1. And both momentum and energy will conserve for elastic collision. That's we have to keep in mind. So similarly, energy will remain conserved. So it is half m1 u1 square plus half m2 u2 square is equal to half m1 v1 square half m2 v2 square. Here I have not used the vector, because when I'm taking the square of some vector quantity, that will become a scalar, right? So that's why I have not chosen here vector. Let me call this as equation number 2. Or this can further be modified because 1 by 2 is a common factor. So I can express it as m1u1 square m2u2 square is equal to m1v1 square and m2v2 square. So this is the equation number 2. So let us rewrite these equations. This is before collision and this is after collision, right? Let me rewrite equation number this as this is m1 bringing this towards this side means it is u1 minus v1. Both are acting along the same direction, so I can simply write down it as m1 v1 must be equal to m2 v2 minus u2, bringing this towards that side and this towards this side. And let me call this as equation number 3. And here I can write down m1 u1 square minus v1 square is equal to m2 v2 square minus u2 square, and let us call this as equation number 4. Now let us do little algebra. So I will use the operation that dividing 4 by 3, and if I do this and this 4 can be expanded, so I can write down it as m1 u1 minus v1 u1 plus v1 divided by this, it is m1 u1 minus v1 must be equal to m2 v2 minus u2 and v2 plus u2 divided by m u1 minus u2 minus v2 minus u2, right? So that's what will happen. To do this, my motive is to calculate find out the relationship between these velocities. So here this will cancel out. Similarly, this part will cancel out with this and this part will cancel out with this. So finally what I am getting, that is u1 plus v1 is equal to v2 minus u2, or in other words I can say that u1 minus u2 must be equal to bringing this towards this side and this towards that side, so it is minus v1 minus v2. So this is the difference of two velocities, initial velocity and the difference of the final velocities, and their difference is basically represents the relative velocity. So this equation number 5 shows that in an elastic one-dimensional collision, the relative velocity with which two particles approach each other before collision is equal to means basically I'm talking about this part, and is equal to this one means it's equal to relative velocity with which they recede away from each other after collision. This negative sign indicates this the receipt, right? That's we have to keep in mind. We have to understand the language mathematics, right? Now, next I will try to find out the velocity of each particle after collision. That means I am interested to find out v1 and v2. So let us now calculate the velocity of each particle after collision. So using equation 5, let me go back. This is the equation number 5. So I am using this equation. So using this equation, I can calculate V1 and V2. So V1 can be written as V2 plus U2 minus U1, and V2 can be written as V1 plus U1 minus U2. So substituting the value of V2 in equation 3. So if I use this value in equation number 3, then what I am getting? I am getting M1 U1 minus V1. It must be equal to M2 V1 plus U1 minus U2. This is the value which I am using, minus U2. So from here I am getting M1 U1 minus M2 V1 sorry, I'm interested to calculate from here the value of V1 because I have eliminated V2. So it is M1 U1 minus M1 V1 is equal to M2 V1 M2 U1 with plus sign and M2 minus M2 U2 minus M2 U2. So both can be put together. So let us take this here. So I can say that M1 minus, if I bring this towards this side, that means it is M1 minus M2 U1, right? And bringing this towards this side, so it is plus 2 M2 U2 is equal to M2 V1. M2 V1 plus m1 v1, bringing this towards this side, right? So that's what I'm getting. My motive is to calculate this v1, so I can do one thing. Let me simplify it by using that it is equal to m2 plus m1 into v1. So if I put it here and this dividing by this, then what I'm getting that v1 is equal to m1 minus m2 u1 plus 2m2 u2 whole divided by m2 plus m1. That means this v1 is equal to m1 minus m2 over m2 plus m1 u1 plus 2m2 over m2 plus m1, and it is u2, and let us call this as equation number 6. And similarly, using value of v1 in equation 3, we will get that m1 u1 minus v2 plus u2 minus u1 must be equal to m2 v2 minus u2. And doing little algebra, from here I can calculate v2, and v2 comes out to be m2 minus m1 over m1 plus m2. It is u2 plus 2m1. It is m1 plus m2, and it is u1. So let me call this as equation number 7. So these are the velocities of the particles after collision, and it depends upon the initial velocity and masses of the particles, right? So now there are different cases which comes out and which needs to be discussed. So this is the equation number 7 which we are getting, right? So this is the equation. So this is the equation which we are getting. So let us take different cases. This is the case number 1, and then I will talk about case number 2, and I will talk about case number 3 and 4. There are 4 cases which I will discuss. So in the first case, I will take that particle 1 at rest, one particle at rest. So at rest, so that means let us assume that m2 will be at rest. That means its velocity will also be 0, m2 at the rest. So if I use the value of u2 is equal to 0, then v2 comes out to be and let me do one thing. I will bring here the 6th equation also. So let me copy it. Yeah, and bringing this towards the next slide. Let me go back. Okay, let me write down this V1 again. Let me go back. Yeah, next page. It's the next page, right? So let me try to write down it as also. And it is V1. And the value of V1 will be, yeah. So V1 is, it is V1 is equal to, it is M1 minus M2 divided by M1 plus M2, sorry, M1 plus M2, right? And it is U1 plus 2M2 over M2 plus M1, and it is U2, which we have to keep in mind. Let me call this as equation number 6. So that means if M2 will be at rest and U2 will be 0 and U2 will be 0, so that means this term will be vanishes, and this term will also vanishes. So that means if I put these values here, then I can write down the value for V1, and V1 is equal to, from here, V1 is equal to M1 minus M2 over M1 plus M2 into U2. Let me go back. Sorry, it is U1. U2 will be 0, so that means it is uh, U1, right? And similarly, I can write down expression for V2, and V2 comes out to be 2M1 M1 plus M2 into U1. That's what I'm getting, right? So now let us take the second case. This is the first case. In the second case, particles mass will be same, masses will be same. That means M1 is equal to M2, and let us call it as M. So if I put the value M, both are identical, so that means this term will vanishes, and here this term will also vanishes. So that means V1 can be written as this 2M2, and this is M. So both are equal, so this 2M and 2M, this will cancel out, so it is U2. And similarly, I am getting that this V2 is equal to U1. That's what we are getting from here when both the particles are of same mass. So this means that in 1D elastic collision of two particles of equal mass, the particle interchange, the particles interchange their velocity means this v1 will become u2, velocity of the second particle before collision, and v2 will become u1, means it will become the velocity of the first particle before collision, right? So interchange their velocities after collision. That's what we are getting, right? So this is the second case. Let me go to the third case now. Sorry, not the third case, but let me do one more thing here. Now, if m2 is equal to m, m is at rest, that is u2 will become 0, then v1 will become 0 and v2 will become u1. That means if m2 equal to m, means masses will remain the same, or I can say that m1 is equal to m2, and which is equal to m, means both the masses are remains the same, and then one particle will at the rest and another is moving with velocity v1. Then what will happen? The particles interchange their velocities, and due to this, what will happen? That if second particle will at the rest, then after collision, first particle will comes at the rest, and second particle starts moving with the velocity of the first particle. That means, hence, first particle of mass m1 comes to rest after collision, and second particle of mass m2 acquire the initial velocity of the first. This is the case, right? But here both the particles are of the same mass. That we have to keep in mind. This is here m1 m2 we have taken just for the just make the difference between the particles. Otherwise, both m1 and m2 are of the same mass, right? So then, let us take the third case now. Here, m2 is very heavy, that is m1 nearly equal to 0 and u2 is nearly equal to 0, because second is a very heavy, so its velocity will be very small, almost 0. So therefore, m1 plus m2 nearly equal to m2, and if I put these values here, this is nearly equal to m2 and this is this, and m1 minus m2 nearly equal to minus m2, keeping all these things in mind. And similarly, m2 minus m1 is nearly equal to m. So that means this v1 will be equal to minus u1, and V2 will be equal to 0. And this means that, let us have a look at that. What does it mean? This means that, or this shows that, when a very light particle collides against a very heavy particle, at rest, the heavy particle continues to remain at rest, because if u2 will be 0, then v2 must be equal to 0, continue to remain at rest, while the velocity of the light particle is reversed. While the velocity of the light particle is reversed. That's what we can see from here, because v1 will become equal to minus u1, so it gets reversed, right? So that's what will happen. Now let us go to the fourth case. Let me go to the fourth case. This is the third case which I described. Now let me talk about fourth case. For the fourth case, particle at rest is very light. That means, let me assume that m2 is very light, means nearly equal to 0. So that means m1 minus m2 is nearly equal to m1, and it is also at rest, so u2 will also be 0. So what does it mean? If I do this little substitution in these two equations 6 and 7, then v1 which I am getting, that comes out to be, this v1 in the fourth case is equal to u1, and v2 is equal to 2u1. That's what we are getting for this case. You can do little algebra and you will get these results. This is not a very big task that you have to do. So this shows that velocity of heavy particle remains almost same after collision. That's what we are getting out of it. And light particle acquire twice the velocity of the heavy particle. That's what we are looking at it using this part. So that's all for this collision, elastic collision, one-dimensional elastic collision in the laboratory frame of reference. So that's all for this lecture. In the next lecture, I will discuss the such type of motion in the moving frame of, sorry, in the center of mass frame of reference, right? So that's all.